Hello everyone, today we're going to be doing a projectile motion question. So here in this question we have a particle moving along at whatever position we want. And they give us the velocity of this particle. And they want us to find the position and acceleration. So the way we're going to do this is we're going to use the definition of velocity to be the time derivative of the position. Now, if we're cheeky about this, we're able to take this dt and bring it over on this side and put an integral sign on it. This is not allowed if you ask a mathematician, but we're going to do it anyways. And they give us the expression for v, so all we're going to have to do is put that in there and then integrate this equation. So we want to integrate the value for v, which is h to the 4 bt plus c. And that's going to give us our position. So doing this integral now, we have at to the 5 over 5 using the power law plus bt squared over 2 plus ct over 1. And then we have our constant of integration. And that's going to equal our position. Now, notice that in the question we are also given this initial condition, and we're going to use this initial condition to find what the value of our constant is. So we know that the value of x at t equals 1 is 0. So when t equals 1, we have a times 1 to the 5 over 5 plus b times 1 squared over 2 plus c times 1 over 1 plus constant. And we know that that's equal to 0 from the value of how they define it. So using this, we can substitute and find for our constant. So a over 5 plus b over 2 plus c is equal to minus constant. I'm taking the constant over to that side now. So therefore, our constant is equal to minus a over 5 minus b over 2 minus c. So using all of this, we're able to write down the position. X of t is equal to, and we're going to use this equation here and substitute our value in for constant. So x of t is equal to at to the 5 over 5 plus bt squared over 2 plus ct minus a over 5 minus b over 2 minus c. And that is the value for our position. It's very easy to get confused with your integration constants if they already have a c in your equation, which is why I prefer to just use the word constant. So then it's harder to get confused when you also have a c in there. So great, we found position, and now we're going to find the acceleration. And we're going to do this by using the equation for acceleration, which is just the time derivative of the velocity. So taking the time derivative of the velocity now, we have d by dt, at to the 4 plus bt plus c. That's equal to our acceleration. So again, using the power rule, the 4 comes down, the t to the power of 1 comes down, and the constant goes away. So taking the time derivative, we have 4a t cubed plus b is equal to a of t. There you go. We have found both the position and acceleration of this particle as required. Now, notice in this question, if they had given you more values of x of t, we could have sequentially found the values of a, b, and c just by plugging in more values. And then that would be able, using that, we would be able to solve for the constants. But they don't, so we're just going to leave them in the form of the constants they give us. That's all I have for this video. Thank you, everyone.